Hi everyone, and thank you for joining my talk. I'm Pardis Emami Naimi, and today I'm going to talk about our project to specify the content of an IoT privacy and security label. This is a joint project with my colleagues Yuvraj Agarwal, Lori Craner, and Hanan Hipshi at Carnegie Mellon University. IoT devices are everywhere. Some of the most common ones, which you might also have at home, are voice assistants, smart doorbells, smart security cameras, smart thermostats, smart toothbrushes, and smart light bulbs. And some less common ones are smart salt shakers, smart forks, smart umbrellas, and the most controversial of all, the smart toilets. And the list goes on and on. People are increasingly purchasing smart devices. However, despite the surge in purchasing them, consumers are concerned about the privacy and security of the smart devices they purchase. And people should be really concerned about these devices. After all, we have seen news on how easily security cameras are getting hacked. But sometimes risks could have been mitigated if users of these devices were more informed. For example, after Ring's security cameras got hacked, the company emailed their millions of users to use multi-factor authentication. So maybe these devices would have not been easily hacked if users knew more about better and more secure authentication mechanisms. You may have also heard about Google putting its consumers at risk by forgetting to mention that its Nest Secure Hub had a microphone. Or in other words, failing to inform consumers about the device sensors. Another example showing how currently manufacturers are not transparent about their privacy and security practices is when some smart TVs are selling our data to third parties without disclosing it, or when it got revealed that Amazon is sharing unencrypted recordings of users' voices with its employees. Therefore, in many data collection scenarios, consumers are not informed about who their data is being shared with or sold to. So what we need here is to find an effective way to show this information to consumers. And this is what we explored in this paper. We designed a privacy and security label for smart devices, somewhat similar to nutrition labels for foods. Our design label covered various privacy and security attributes related to the smart device. And as you can see, we include some of the important information that IoT companies are not disclosing to consumers, such as access control, sensor type, data sharing, and data selling. We designed the first version of our privacy and security label last year. I conducted a study to explore IoT consumers' perceptions of our designed label. Almost all of our participants reported that they would like to know about the privacy and security of smart devices before making device purchases. We also asked them how much of a premium they are willing to pay, if any, to have this information available at the time of purchase. Almost all of them reported that they are willing to pay 10 to 30% of the base price of the device to be provided with this transparency, mostly because of the perceived assurance that their privacy and security would be protected and peace of mind. From this study, we found that it's currently very difficult for consumers of IoT devices to find information about the privacy and security of smart devices at the time of purchase, and that they are very excited about the idea of having privacy and security labels at the point of sale. Several pieces of legislation have been proposed, both inside the US and in countries outside of the US, including the UK, Singapore, and Finland, that would require IoT labels. Some even mention a few factors that should be included on these labels, but they don't contain too many details about what the labels should look like. And as you can see from the headlines, the proposals are primarily focused on security attributes, without much attention of privacy practices. So our question here was, what should be included on an IoT privacy and security label? To capture a holistic view, we invited a diverse sample of experts from industry, academia, government, and NGOs. To elicit experts' opinion on the privacy and security factors, we followed a 3-round Delphi process. In the Delphi method, the objective is to reach a consensus among a panel of experts without these experts directly influencing each other's opinions. This consensus is usually reached by conducting multiple rounds of interviews and surveys. In Delphi method, we have this concept of controlled feedback loop, which means that the aggregate output of the previous stage will serve as the input to the next stage. We have this feedback loop to allow experts adapt their responses and eventually converge. Experts had to satisfy at least one of the following criteria: being a computer science or engineering faculty member in the field of privacy and security, having more than 10 years of research or practice in privacy, security, or policy, being an author of known books in the field of privacy and security, having active involvement in cybersecurity standardization, or leading an IoT product team in industry. And 7 of our experts met 12 of these criteria. The first stage of the Delphi process is mostly an interview study. We conducted semi-structured interviews with experts and asked them to specify the most important privacy and security attributes to include on the label. These interviews resulted in 47 privacy and security factors that at least one expert wanted to see on the label. We then conducted the first follow-up survey, where each expert was randomly assigned to review 1/3 of the attributes and specify their importance, as well as their reasons supporting their decisions. From this stage, we found the most common reasons to include or exclude a factor and presented these aggregate reasons to experts on the second follow-up survey, where each expert was randomly assigned to review 1/3 of the attributes, and once again, we asked them to specify whether they would like to include or exclude factors now after seeing all the reasons from the previous stage. And this is where we have this controlled feedback process. To analyze interview responses as well as the open-ended answers from the surveys, we conducted thematic analysis, which is a recommended qualitative analysis approach when information is high in subjectivity. We followed a 6-step procedure recommended by Brownell Clark to create the codebook, find the themes, and merge them. Experts acknowledge the value of the label in informing consumers' purchase behavior. An expert mentioned, quote, "What's good about a label is that it empowers the consumer to make a more active decision about cybersecurity rather than just being completely helpless as to what the security of her device might be. The average consumer doesn't have a privacy, security, or a legal department to review this stuff before they buy it. Enterprises do, but consumers do not. So someone's going to be looking out for consumers and giving the consumers this information." In addition to informing consumers' purchase behavior, some experts reported that the label could be a forcing function for manufacturers to be more accountable and transparent about their privacy and security practices. Moreover, experts mentioned that if the label gets adopted, it could initiate a competition in the market for manufacturers to enhance their practices. An expert said, quote, "There is value in forcing the company to write a list down, even if the consumer doesn't understand it. If you said, list your open ports, there would be an incentive to make them few." As I previously mentioned, experts wanted us to include 47 privacy and security factors on the label, which is clearly too many to show on a typical product package. Therefore, we decided to design a layered label with 2 layers. The primary layer is the concise format of the label, which could be printed and attached to the package of the product. Then there's a QR code and a URL at the bottom that direct consumers to the secondary layer, which has more detailed information and is in an online-only format. Online format means that it can be updated as firmware changes, which is critical as devices get updated often. Another important reason to have this online layer is to have a way to accommodate IoT companies updating their privacy and security practices. Some of the attributes we included on the primary layer were security update lifetime, collected data, availability of automatic security updates, and availability of default passwords. Second layer has all the information from the primary layer and a lot more. Some of the attributes we presented on the secondary layer were retention time, data inference, data storage, and whether there is any special data handling practices for children's data. To assess our label's usability and information communication, we recruited 15 participants who have purchased at least one smart device. We then conducted a 1-hour semi-structured interview with each participant. And by following a user-centric design process, we iteratively improved the design of our labels. We tested the label's risk communication and information comprehension in both non-comparative and comparative purchase process. We started with a non-comparative process and asked our participants to take a look at the package of the smart device with our label on and define the attributes as well as their values. We then asked them to specify the information that conveys risk to them. In a comparative scenario, participants imagine doing comparison shopping for a smart device from two different companies. We asked them to compare the labels and specify which company had implemented better privacy and security practices and why. Most of our experts believe that consumers would find the layered design of the label to be confusing. However, in our user study, only a few participants preferred having a single layer label, mostly because of the perceived inconvenience of using their phones or using a QR code scanner to see the secondary layer. And the second reason was this feeling that company is hiding some information from the consumers by including it on the second layer. Most of our participants, however, preferred having a layered privacy and security label, mainly because a layered label would fit more useful information than a single layer, and they would readily get insight into the information of the primary layer as well as additional privacy and security practices of the IoT company. Some of our consumer participants reported that our label is useful to inform both consumers and experts. A participant mentioned, quote, "Labels are both for customers and experts, such as tech journalists and consumer advocacy groups. If they see something that is questionable, they will raise it in the public press or will raise it with regulatory authorities. The label is not just for the consumer, but there is another feedback process that works through experts." Based on a series of interviews we had with consumers, we applied some changes to the label. A few of the things we changed were to move attributes such as data sharing and data selling from the secondary layer to the primary layer, and another change was to remove the icons that we previously used for security update and access control. Our experts believe that automatic security updates and no factor reset default passwords are two of the most important security practices that consumers should know about. To differentiate these attributes from the rest of the label, we used to show a smiley face or a frowny face. However, our consumer participants expressed negative attitudes to this choice. They reported that they would perceive these indicators as marketing tricks, pushing them to purchase or not to purchase the smart device. Therefore, we removed all these icons and used a neutral language to convey this information, similar to the rest of the label. In an iterative process, we also applied several wording and design changes. And this is a version of our label from last September. In this project, we did not test the design of the label. However, from the literature, we already know that one of the factors that could significantly influence the risk communication of the label is its design elements. For instance, the fonts used or the order of the factors and the order of the sections. This is an important topic that should be explored in the future. In addition, in the project that I described today, the responses were all self-reported. Therefore, it's valuable to test the effectiveness of our label in more realistic settings. In addition to the label, we prepared a specification document for users and IoT manufacturers. The content of our specification is based on the previous studies we conducted with consumers and experts and more than 70 IoT privacy and security references from industry, nonprofit organizations, government agencies, and academia. In this specification, we provided a taxonomy of the label, consumer explanation for each attribute, and for each attribute we also provided a list of items to include as the additional information and a list of best practices from various references. As I previously said, the primary focus of current IoT standards and guidelines is security. And unfortunately, there is little available guidance on the privacy of IoT devices, and except a few, they are not tailored toward consumers. We, on the other hand, put a huge emphasis on consumers to make sure that the final label has enough elements to convey risk to them and inform their decision-making. For real-world impact, we would like to have our labels adopted. And to ease the process of generating the labels, we developed a tool that allows users to complete a form for these sections of the label and see the label being generated in real time, as you can see from this record screen here. In the most current version of the tool, users can download the label in the formats of JSON, XML, and HTML, and users can also work on the label offline and then upload the saved JSON file to resume working on it. Smart devices are not transparent about their privacy and security practices, and a label could be useful to provide that much needed transparency and inform consumers' purchase behavior. To specify the content of the label, we conducted interviews and surveys with a diverse sample of privacy and security experts. We then conducted a series of user studies to evaluate the designed label. And to ease the process of label adoption and generation, we prepared a specification document as well as a tool to generate the label. And if you want to know more about the recent version of the label as well as the specification and the tool that I just showed, you can visit IoTsecurityprivacy.org. Thank you so much for listening to this talk.